back. In this video I'll be solving Leetcode problem 63, unique paths number 2. So essentially same as previous problem, unique paths, but here we have some what is it called, obstacles. So that will change a bit our solution. So let's try to solve it. First we'll do top-down solution and then bottom-up. Directions, same thing, 0, 1. We'll need cache and go again x and y, but this time well, I'll do the same logic. So if x, y not in cache, then we return it, return cache of x, y. Okay, if it's not in cache, then we need to figure out so if we have so first condition, if since we're going again down and right, we need to check if it's out of bounds and also if it's 0. So if it's obstacle, let's do it all in one. So if x is greater or equal length of obstacle grid of obstacle grid or y zero, or let's of x, y. So if it's 1, return 0. Other case is if x, y is x, y is equal maybe I should have done this, so m is equal this, n is equal this. And if neither of those cases is true, we'll count and cache of xy is equal count. And that seems it. So the only difference is that we actually check this part. And we are given a grid. So here we return go of 0, 0. Let's see if this works. Seems okay. Let's try submit. So we did solve it, and we have bottom-up top-down solution. And again, it's a same story, m times m times n for both time and space. Yep. Okay. Let's see if we can do this. So bottom up, and can we make it better? And the answer is yes. So same thing we had previously. I'll just delete these two and all of these. So when you look at it, it's essentially the same thing. So we can go either down or right. So we can go here or there. The only thing we need to be careful about is that if the grid position has an obstacle, it's for sure 0. So can do last row is equal one if one for I in one for I in so I need to flip it. Okay, it's 1 minus I for I in obstacle grid of -1. So I'll flip the values. If it was obstacle, then it will be 0. If it's not, it's 1. So that's this part. Yeah, I think that's it. Yeah, when I think about it, that should be it. So for am I in, well, actually, what do I have here now? So I have these rows. This should be ni. So for ni in length n, doesn't have to be a square grid, or yeah. So ni for, and here I go and -1 because I don't want to do the last one. for mi in range length of, so again this time m, because I want to pass through all of them. Yep. So I need to do, for each this one, I need to do new row which is again, or I can just call it 0, 0 times m. So new row of mi, and again I can do this -1 So new row of mi, we will skip the last one because it's 1. Yeah, let's do the same thing. So 1 is equal to last row so last row either last row mi plus new row mi plus 1 if and that is if obstacle grid of ni mi is not equal 1, then I do this. If it's 1, if it's 1, then this is 0. And when I finish with it, last row is equal I for I in new row. And in the end, I just return last row 0. My length. Okay. Not sure what was with those lengths. So new row of last row of mi. Actually m minus 2. Okay, same side. So last row of mi. Okay, seems all right. Well, yeah, it is all right, but this checking is not correct. So again, I want to skip last one, and this should be good now. Well, 1 is good. So second example is not working. There is only one way. well, yeah. One if obstacle grid of so ni minus 1 is equal 0 else 0. So something like this. So if it's obstacle, okay, this was a bit. Well, if it cannot go to the this kind of edge cases, so well, last row has to be also built. So if obstacle, as you can see, it's sometimes harder to take care of each edge case here and think about it. So if this is equal 0, then I can do this. Else why is it 1? So it was zeros. So new rows are all zeros. New row of -1. So the last is 1 if obstacle of ni -1 is equal 0. Well, yeah, it's kind of not true, so this should be correct. Okay, I kind of messed up, it seems. So 0, 1, 0, 0. So new row is all zeros. New row of -1. It's not the last row of -1. If if ni minus 1 is not equal 1, if it is, then 0. Okay, I'm getting closer. So this one is crazy with edge cases. So if one obstacle so even last row I cannot do it without so this would be appropriate. So flag last row is, if it's 0, then I can keep it, but I'll just put 0 times m for I in range. So m minus 1, minus 1, minus 1, minus 1. If I is equal 1, y is false. So last row of I is equal 1 if flag else 0. Something like this. Okay, so not very nice, but probably could have been done better. So this was actually what I needed. Minus 1. Yeah, I don't even need this. This was actually what I needed, but I did not see it at first. Let's try it out now. Yep. So it's not that ugly, but it's not even that nice. You just have to be very careful. So we need to do the last row. And last row is once, only if there is no obstacle, or if it is, everything after obstacle is 1. Only if obstacle is at the end, then everything is 0. So that's the last row part. And here is the upper row. And in upper row, we check if we can reach the destination from the rightmost cell. If we can, then we start the calculation as we did in previous one. So yeah, didn't solve it perfectly, but I think it makes sense, kind of more edge casey. If you're not careful. No. So O of M, because we stored the row, and here's again M times N. Let's check space and time complexity and M and M. Okay, I hope everything here made sense. If you have any questions, leave them in comments, and I will see you in the next video.